Hi, everybody. Thanks for joining our quick talk on AWS reInvent Recap. Today, joining me is Miguel Ferreira. Miguel is AWS Solutions Architect, focusing more on AI solutions. I'll let him introduce himself. A few quick words. Miguel, please.
Hello, so I'm Miguel. I work as mentioned as a solution architect, and I'm based out of Helsinki, Finland. I also work with customers in the Baltics and in other Nordics countries mostly. And yeah, specifically with advanced customers, ISV customers who are quite experts already in the AWS platform, and we're helping them, adopt new services and new use cases on the clouds, on the AWS clouds.
Yeah, cool. And I'm Jonas. I'm a customer success manager here at Cloudvisor. Most of our customers probably have already met me, but if not, yeah, hi. And yeah, I'm working with our customers. Mostly they're startups from all over the world. Most of them are early stage startups, some of them are mid stage or late stage. But what unites them is them being startups. And yeah, we're always thinking what and which of the news that AWS brings every year, which of them would be the most applicable and most important for them. So yeah, I think we can start our conversation, kind of discussion today, from the obvious things. Well, I think one of the key differentiators for AWS is that, well, it's the biggest cloud, and each year the numbers still keep amaze me. This year, Adam mentioned that there are 32 regions already up. It's planning for 5 more.
Yeah.
And those regions are unlike other clouds, right? So they at least have 3 availability zones, which are not like data center. They could be a cluster of data centers even. And yeah, it's basically 3 times more of data centers than the closest competitor. And I think especially for startups that have huge ambitions and want to start on the right foot, on the right cloud, well, AWS probably is the only choice if you want to be if you want to expand effortlessly and reach global audience. So yeah, that part each year is just keeps increasing. That still amazes me. Yeah, but perhaps you have, Miguel, have your take. What does
Yeah.
that mean? How does that translate to other opportunities?
Yeah, you're exactly right. I think we are expanding. I think if you look at the history of the region announcements, you'll actually see acceleration there. So
Yeah,
we're announcing more and more in Germany. In Europe, there is Germany. That's the new region that has been announced. I think the latest to be announced, with 3 new availability zones, as you well mentioned, a very important concept when you design workloads on AWS. And beyond the regions, we also have, of course, the local zones, which are more focused on, cities. You could think of them as one availability zone, so it's not as big presence as a region, but it's still quite significant.
but they're
And then we have, yeah,
the users, right? The population. Yeah, that's a nice
yeah, very
differentiator.
close for very low latency, usually centered in large urban areas where there is a lot of compute demand, and so that it can be very close to the end customers. Then we have the points of presence where you can ingress into the AWS backbone, the direct connect. So you can have a private link to the AWS backbone so that then your traffic travels within that backbone. And we have, of course, the outposts where you can bring a piece of AWS into your data center if you wish. And then we also work with telecom providers in the wavelength zones. That's another one.
Yeah,
Which we are expanding as well. So yeah, quite a lot of places where you can run using the same APIs, the same control planes. You can run AWS workloads on AWS.
it's a huge selection of different areas to deploy your resources. Yeah, either you want to have more control in your confined space in your data center. Yeah, you can bring, as you mentioned, outposts. That's like a huge deal then, and no other cloud competitor I think offers that. So it's interesting concept. Yeah. Um, Another thing that AWS associates to myself is not only expansion, however, it's also huge on innovation. It innovates at the make break space, and basically each year they just bring a huge tidal wave of announcements, and yeah, they're just gathering up them through a year and then release the floodgate, and they come out. One of the areas that basically always uh, keeps me interested is the Graviton step towards a ARM architecture and their introduction of their first Graviton CPU back in, what was it, 2018, right? Somewhere around that time frame. And yeah, since then, basically every year they keep updating, and they're coming out with new generation of their ARM architecture based CPUs. So it's currently the fourth generation already. I think we'll lose count quickly, but yeah, I mean every year it's 30 to 40% better than the last year. And what that translates to is that it's better price to performance. They cost basically the same, but they're way better. They use less electricity, so that's why they can be cheaper per dollar per performance, right? And they in turn are more sustainable for companies that are really looking into that. And yeah, this one, this step, having this scale, of course, probably the scale dictated this step, right? Let's be honest. But yeah, no other public cloud actually did it. So yeah, how do you see this one?
Yeah,
What's the importance of the Graviton to AWS?
I think actually that was a really good strategic investment very early on. I think I'm sure we had the first ARM instance in the cloud when it released with the A1 instance type, the first generation, and I mean, and before that, we were already investing in our custom silicon with the Nitro. So Nitro is a way of offloading a lot of what the hypervisor does in the host machine into a specialized dedicated hardware, which makes the hosts themselves more secure, less things to handle, and deliver more power to the end customer. So that was the beginning of our custom silicon. And then we started designing Graviton, which became ever more powerful. Like as you well explained, these are simpler kind of processor designs that are adequate for most of the workloads that people run, like web servers, databases, and things like that. And consume less energy because they are simpler and they are well suited for these workloads. So you might need in some very specific use cases still to default to one of the Intel or AMD architectures, but in many cases, ARM is the way to go. We make it also quite simple. So of course you need to consider if your application is compatible, all your libraries have ARM compatibility and so on. Typically, when you are dealing with more modern applications, it's easier, like interpreted languages and things like that. We also make it easy if you use our managed services, like database managed service RDS, to
Correct.
switch to Graviton, or Lambda, where you can use the runtimes that Lambda provides and just make the switch and benefit from the cost efficiency with a very simple configuration change, basically.
Yeah, as you mentioned, yeah, the ARM architecture is a bit different from the traditional x86, and some of the vendors like Intel or AMD might have some of the instruction sets or capabilities that are actually leveraging some of the functionality that customers might need. That there might be, I know if I will be right, but maybe something related with hashing or encryption, so some kind of specific libraries or instruction sets that are making that possible, or better or faster. What the Graviton doesn't have, as it's a little bit more, as you mentioned, simpler, but it's for, let's be honest, I don't know, 99% of workloads that fits just beautifully. Yes, there is a little bit of a step you have to take, right? So a little bit of rewrite, a little bit of importing different libraries. Most of the open source libraries, they do have different versions for different architectures. So that's not a very huge change. And of course, the sooner you make the change to ARM, the easier it is, because later on you just accumulate a little bit more and more debt that you have to repay later. And yeah, I would say running the infrastructure in some cases can be way more expensive than actually designing it to be run on ARM or be run in a smart way. So yeah, sometimes upfront costs are daunting, but and in the long run, in most cases, it can be just a very wise investment.
Exactly. And then you see also that the kind of the chips that are purpose built for certain types of workloads, like machine learning.
Yeah.
And you have also heard about the Trainium and the Inferentia, which are also ARM-based chips. So this is where we specialize the design of the chips to specific use cases that require a different architecture, let's say. So still according to the ARM standard, but specially designed for these types of use cases.
Yeah,
So
like
yeah,
specialty built chips. Yeah, and
exactly.
speaking of that as well, AWS just announced the second generation of the Trainium chips. Again, it's not 40% faster this time; it's 4 times faster this time than the first Trainium chip. It's a huge leap forward. Like, do you have any insight of what did they do this time to achieve this kind of?
To achieve this, I think it's of course more density, more cores, but in this case also more memory bandwidth, which is important in these training use cases, and the possibility to link them in clusters. That's the new thing also with Trainium, is that in many of these really large-scale machine learning training jobs, especially when we're talking about the new large language models, you need days, weeks of training. And why? Because you have just a certain amount of GPU, and there is actually constraints. If you make a distributed cluster for training, for example, there are constraints because there are latencies between these different instances. So what Trainium does with a specially designed architecture is allows customers to create these ultra clusters that provide a very low latency and high bandwidth between the instances, so that you can create huge multi GPU clusters for the training jobs, speeding them up further. And we have big names like Anthropic training their models on Trainium, and Stable Diffusion, Stability AI training their Stable Diffusion models. So that they have clearly stated how the speed gains and the efficiency gains that they achieve with this hardware.
Yeah, it's no secret that AWS is becoming more and more of a commodity supercomputer. Like, you can build one if you like. Of course, it costs a little bit more than a regular instance, right? But you have the ability to build your supercomputer for a couple of hours, and you can run it and you can train stuff, or use it for other types of calculations. Yeah, the old EC2 ultra clusters you mentioned, right? So they're way better interconnected together. They can interconnect GPUs together, processors. I mean, it's like having racks and racks and racks of servers whenever you need it. It's a great proposition, actually, to create such a supercomputer out of disparate EC2 machines. That would be quite an undertaking, but AWS just made it super easy.
Exactly.
Yeah, that's really cool news, and really cool opportunities for customers who might be looking for extra horsepower. And since we started looking into machine learning topic, is that rising compute power actually is diverted or is fueled by more and more need and demand for those machine learning algorithms models to be trained, to be retrained, to be fine-tuned. And we are building way bigger and bigger models themselves with billions of parameters. It's like now it's over 100 billion of parameters. Like, it's mind-boggling, but they do work and they do make our life easier, and probably will make many of AWS customers' lives easier, that we will quickly touch on a little bit later. But yeah, the big news is I think the Bedrock service that was launched well a couple of months back in a kind of beta version, closed version. But customers actually did try it. It was mentioned it was quite enthusiastic approach from the customers that AWS finally brought this into the space, and it brought it with all the bells and whistles that we love AWS about. So it's compliant with all the standards. It is equipped with robust monitoring with CloudTrail. It's also it's employed in your environment together with guardrails that you basically would tell the model what is off limits, what you shouldn't be thinking about or talking about, right? That's really cool that AWS gives all this overpower on the model itself, and you are able as a consumer to well fine tune, provide it its own data, and make it your own kind of, and host it on AWS, and you don't have to build a supercomputer to host this, right? So
Yeah.
that's a really cool thing. Yeah, Miguel, what's your take? What was the journey in AWS? Perhaps you have a sneak peek for us, like how did this came
Yeah.
to life?
Yeah, Bedrock was a huge thing for us, definitely. I mean, we all see the power of these models, and not everybody has the budget to train or deploy, even host a
Yeah.
model like this. You need GPU, and so the possibility to make them available, and also make not only the closed source, some like state of the art closed source models, but also open source models. With the first one we made available now, Llama from Meta
Yeah.
is behind Bedrock as well. So, and like you said, it integrates with all the rest of the AWS services. So it gives you a really powerful way to build large language model powered applications by invoking these models through APIs. And then if you want to add some management features like like you said, guardrails to prevent the model or prevent certain queries and certain outputs to be delivered by your application, or if you want to implement some logic around these models where they call external APIs or they consult your document database. So you can do that with Bedrock agents or Bedrock knowledge base. So yeah, a lot of possibilities. Again, we give you the building blocks. I think it is the best place to build LLM powered applications. Whereas other companies might be investing in one, big LLM, and they are pushing the boundaries. We are really focused on making available a diversity, because we know some of these models are better at some things.
Yeah.
And so we want to make them all available for you to pick and choose. There was another feature announced, actually, I don't know if you noticed, it was the model evaluator in Bedrock. So that allows you to send a prompt and target more than one model, and then be able to evaluate and test as you evolve your prompts, how well these different models perform with the changing prompt. So this is also a very handy, I would call it, management feature over the the Bedrock core, which is the API that allows you to target any of these models.
Yeah, and bringing a couple of those models that are big players in the space. I mean, it's a huge advantage for AWS and for AWS customers to be able to eventually use each of those models, or as you mentioned, to basically just quick test them. How do they perform for their task? And it's no surprise that there is no one best model, right? We
Exactly.
will be building more and different models, and they will be bigger. Some of them will be smaller or more focused, and there will be niches for I think maybe every model. Some customers will find that that's the sweet spot for their workload, and bringing these what, like it's 6 or 7 models right now on Bedrock, right? So it's like Anthropic's Claude, Jurassic 2, Stable Diffusion, Cohere's Command and Embed, Meta's Llama, as I mentioned, and Amazon Titan. This one is interesting, actually, because this is kind of you guys bringing the your own knowledge into the space, right?
Exactly. Yeah.
Working with ML for more than 20 years.
Exactly. I mean, look at our facility centers, how they operate, the logistics of it, the automation there. Look at Alexa, the voice assistant, and all the machine learning we've been doing over the years with customers on AWS with SageMaker and other AI services. So yeah, definitely, it's in our DNA. And Titan is kind of like our take on these large language models. I think during the reInvent, they announced 2 new models. There was the image generation from Titan as well, which works pretty nicely, I would say. With the prompt, let's say with Stable Diffusion, I sometimes had trouble finding the right prompt to get the results I need. And it seems this one is more natural language-like for the prompts, but I haven't, of course, tested it extensively yet. And the other one was the multi-model embeddings, which allows you to create basically vectors out of images and texts, so that you can then search, let's say, a catalog of a web shop. Allows you to search based on visual cues that the model understands.
You don't have to label those images anymore,
exactly.
right?
So exactly.
You're trying to talk with a web shop in this example, right?
Yeah.
They're trying to figure out what's in those pictures, so bring you the best results. So these things are exciting, actually. The search is going to become more and more powerful, I think. It's
definitely huge use case.
Yeah.
Yeah.
Yeah, Miguel, you also quickly mentioned on the Bedrock agent. It's kind of hard for myself to wrap around what is the potential for this. AWS said that it's huge, but yeah, Bedrock agents is kind of merging of the Bedrock itself, the large language models, and interaction between AWS services. And in between, there's kind of a logic layer where it would reason what kind of changes need to be made or interactions made, right, across the infrastructure. Maybe you could shed a light to how that's going to work, and what's the what customers could expect, like what kind of mundane work that could move away from their data.
Exactly. So you probably have heard of a library called LangChain. LangChain was how people were building. It's a Python library where how people started building and putting together these different things. Like in a LLM powered application, you have the model itself, and then you might have a vector database, like we mentioned, for search. You might want to go to an external knowledge source, do a Google search, use a calculator, something that the model is not as good doing, or if you think the model doesn't have current information, what's the weather like now? The model has been trained with past data. So these things require some interaction with other systems. What the model is good at doing, though, is to reason and create a plan for executing actions. So if you prompt the model and tell it, this is called, by the way, chain of thought prompting. So there is a way to prompt the model and ask it to devise a plan based on the tools that he knows he has available. So that's also part of the prompt. He will reason and then execute one by one the steps that he needs to follow in order to answer the final question, which might require going to a calculator, to a web search, calling a Lambda function. So the agents is our take on that, managed a way to build these chains of interactions and thought process of the model. So with agents, what you do is you define an API in the Open API specification that the model can process, and it will know the actions it has available. And this API is then connected to a Lambda function. So what you will get is that you'll do a prompt to the model. The model will do its series of steps. And for those steps that require going to these APIs that you defined, it will invoke the Lambda, and the Lambda will return a response. And that response will be then taken by the model to continue in this chain of thought order of processing so basically it's a series of prompts and API calls, which basically is a Lambda call in order to get external information into that large language model. I don't know if I explained it clearly. I know it's
it's just shedding the surface, but do the agents have to be somewhat trained on past actions, or they just use the LLM for reasoning and having in mind their own permissions and connections to other AWS services or other services outside of AWS, what it can do with that prompt?
Exactly. So your agent, as usual in AWS services, you will have a role that the kind of the bedrock agents service can assume in order to invoke your Lambda. And then your Lambda itself has its set of permissions where it can maybe call another service like your RDS database or something. Or if it has a network access to the internet, your Lambda can also go fetch some stuff from an external API. And feed it back. So it works with the IAM as usual for the access. So there is no let's say it's not the model itself having access, it's the service that makes available these orchestration between. So the service will send your prompt. So when you put the prompt to agents, the service will send it to the model, get it back, and then call the Lambda. So it's the service, the managed service that is doing this. Is not the model directly calling this Lambda, but the output of the model kind of tells you what you need to do next. So the service will then use that output to know that it has to call the Lambda for this step to be completed.
Well, basically, those Lambdas would have to still be created by the customer, correct?
Exactly.
So actions that it could make, right?
Exactly. You will need the glue to make So the open, you also need the open API specification. You could use an external if there is like an open API somewhere out there that you'd like to use. You can do that. You can just use that. Then you still need your Lambda to be the one that brings the messages from the Bedrock agents into that external API and then back to Bedrock agents. So you still need that Lambda glue there.
Yeah, cool. I do think it's quite exciting. We shall see some real life applications. I think that will be more encouraging to understand, and more we could have more reference to understand what it's capable of. So I really quite eager to see those and see how that could be applied towards our business or any other customers use case. So that's really exciting, actually. So the time will tell, but the announcement is actually really cool.
Yeah.
Okay, Miguel. Moving over to next topic. I think what's interesting to cover is AWS's constant move towards serverless, and it is doing it step by step. For like Lambda was one of the first services even. So serverless is nothing new for AWS, and as I think Peter said in his speech, that they didn't know how to do it, so they just did it to work, and then tried to figure out what customers are doing with the Lambda. How does it work? What kind of resources do they get? And now how to fit that in that budget? So
yes,
kind of reverse engineering, as you think. And that's really cool. So quite a few innovations stemmed from that, like a Firecracker VMs, like really small hypervisors, and that's a huge technological leap forward, because before that you couldn't do it, and when there's the case, you just find a way how you can actually make it happen. But moving forward, more services started to get serverless offerings, right? So so the last year, I think we got Aurora serverless, and it was quite a breakthrough, because our DS machines databases aren't that easy to scale. You have to shut it down and pull it back up in order to change the size. But AWS just did it with serverless V2, and now it can scale independently and depending on the connections or utilization or whatever. And Peter actually had a quick rundown about how does it work. And again, it was a really cool innovation about routing layer that you guys built that actually allows you to to scale that particular database instance. And in conjunction with Caspian hypervisor, I think it's hypervisor, right? Technically, yeah, which just distributes the host's resources to virtual machines, and if there's no more space, it evacuates it everywhere somewhere else, and it's just seamless. Yeah, just wanted to reflect like how AWS is actually moving forward with this. And yeah, perhaps you have any comments like what this first serverless offering for Aurora last year, like how did it impact AWS and customer choices, for example?
Exactly. Yeah, I think that was a really deep technical talk, really interesting. I think I need to watch it again to really understand all the points. And yeah, we launched the serverless, the limitless, Aurora limitless, basically, as you mentioned, the new routing layer that allows you also to scale the writes, not only the reads. Relational databases are notoriously difficult to do serverless and be consistent and so on. But I think the same as the story with the Lambda, where we started seeing how people would use the service, and then we managed to do more fine-grained environments with the Firecracker and allow it to scale much better and route the workloads much better and utilize capacity much better. I think the same we are seeing with Aurora serverless, basically. So it started off with the version 1, which had some limitations in terms of scaling up and down, the speed at which it did, and it got better with V2, and I believe the new architectures will bring it even closer to what a real serverless, where you don't even need to think about scaling up and down capacity units. You just consume and you pay per request, like you do with Lambda, for example. So that's I think the path is to have real serverless in also relational databases in any kind of. And you have that actually not with relational database, with a database key value store like DynamoDB is the perfect example, where you pay exactly for the request you make to the service, and you don't think at all about infrastructure.
Yeah, and as you mentioned, the limitless offering for Aurora this year, that just came out this year, is actually solving a pretty big problem that more like major customers face. Because if they are on a relational database and they are approaching quite a big scale, and they do have a problem. Basically, they have only a single writer, and that limits their expansion, perhaps their application abilities to do more, because they don't have that headroom. The host can be as big as it can, and that's the limit they were imposed by. So with limitless, it's really cool what you guys did. That yeah, as you mentioned, the routing layer is required to basically split that writer into a couple of writers, as much as you need, basically. And yeah, then you are that limitation is lifted, because if you would ask a customer, hey, your RDS is becoming inhibited by the performance, so why don't you shard it? Like 99% of customers would tell you to go to hell, because sharding doing that on your own is it's an undertaking, and management is a headache. I think you have to have a dedicated team just to be sure that you put the relevant data to relevant database, and the metadata is always synced and nothing crashes. With AWS Limitless, I mean, you just say, yeah, I want this limitless now database, and that's it. It shard your data. If you are growing out from one database into two databases, it will shift over the metadata where those shards are stored, and it's seamless. And I mean, for bigger customers, that's a really huge deal, who are still on the relational database for historical reasons or for transactional reasons. So yeah, that's a really cool invention, actually. But stemming from that, actually, there are other serverless offerings coming up. I think one of the first was the OpenSearch, and
Yeah.
right? The last year, I guess.
Yeah, that was last year.
Elasticache, right?
Yep. And we also announced for open source, we announced the vector serverless vector database. So that's also linked to the previous discussion on large language models. So that's the first vector database where you don't need to provision an infrastructure host, basically. Yeah, just use it, and actually Bedrock integrates with that. So if you start a Bedrock knowledge base, it will create a open source serverless database for you if you ask it to. Yeah, and Elasticache, as you mentioned, that's also the new serverless offering for in-memory cache databases.
Yeah, because creating Elasticache nodes, it's no big deal, right? It's very simple. But to make it adhere to best practices, make them have the right cache at the right time, make it cluster, be distributed through availability zones. I mean, that's something to do. And with Elasticache serverless, yeah, you just pay for the compute that you need, or that is for the requests. And yeah, it's built by adhering to all AWS best practices. It's in multi availability zones, and it scales to whatever size that you need. Rather you need more memory or more compute or whatever, it is there. And it really so simplifies the deployment, and actually probably cost, because Elasticache is notoriously underutilized service. From what I see among customers, it's kind of set it and forget it. You launch once Elasticache, and as long as it works, as long as it doesn't lag, as long as it brings down the application down, it's cool. And yeah, whatever you provision stays there for years. So
exactly.
Serverless options are really cool for that. They could really save quite a lot of money for customers.
Yeah, it's excellent when you don't have a projection of the usage you will actually need. It's excellent. You can just start with serverless. And at some point, if you really want to optimize cost and you know the patterns, the utilization patterns, then you can think of allocating the capacity that is really meeting your needs. But when you don't know that, I think yes, serverless is the way to go.
Yeah, that's a good offering to have, the choice to have, and yeah, it's even easier to deploy. So I think that's quite a crucial thing. It was easy to deploy Elasticache. Now it's even easier. Okay, Miguel, I think we can brush on a few other AWS announcements that caught my eye. One of which was about the S3. So yeah, S3 is like foundational service for AWS. Basically, it's every customer mostly uses it. It's crazy. And one kind of interesting statistics that caught my ear was that AWS intelligent tiering class or lifecycle management, whatever you call it, saved customers $2 billion for enabling intelligent tiering and AWS just shifting around the data wherever it's most supposed to be according to the access patterns, right? What's your take, Miguel? Do you like intelligent tiering? Like, what's the
definitely? Yeah, that's a no-brainer. Yeah, you should just enable it. I mean, we had the option, like you said, to lifecycle objects before. That was a feature of S3 that existed, but then we realized that we can actually monitor the access that customers perform on those objects. So based on that monitoring, we can tell if your object has not been accessed in a month. And so we can just transition those into the most cost optimized storage class since they are not being accessed. So no need to leave them in, let's say, hot storage or S3 standard, and just move it to one of the lower tier storage options, up to Glacier, to tape backups if you want to.
Yeah, and what I also noticed is that I would deal with some customers who actually would have infrequent storage or Glacier Instant Archive storage, but they would actually have quite a lot of requests on that data, and it would be costly. And that's another problem that intelligent tiering solves in my mind. That's really hard to monitor yourself because,
Hmm.
yeah, it's just data. It's all data. I will just leave it there. But
Exactly.
yeah, whenever you need to basically hammer it down once again, it's gonna cost you quite a lot. And with intelligent tiering, it will bring it back. You will use it for as long as you need it, and it will trickle down back to
To the less.
the tier. Yeah,
Yeah.
those are really cool.
Exactly. It is. Yeah.
Another S3 related news was the announcement of S3 Express 1.
Exactly.
Uh, as much as I did understand, that was kind of supercharged S3 class, right? That's only stored on one availability zone,
Exactly.
but it's
Yes.
fast.
Really fast. So basically, it will have its own zonal endpoint as well when you access it. It's a different type of bucket called the directory bucket. I believe the whole backend has been re-implemented in a much more performant way. Also, the storage type used to back that solution is probably faster as well. Uh, and it allows workloads that are really, manipulating data that require this single digit millisecond access to data and a lot of I/O done over the S3 API to do it. So what you need is to place compute in the same availability zone as your bucket, as your
Mhm.
directory bucket, and basically use the S3 API to copy, open, do everything you would do. This opens up new use cases that where you can use S3, like analytics, performing uh, analytics on a large set of data or transformation of the data. It can also enable machine learning, the very fast feeding of data for the training job, which needs, for example, if you think of a computer vision model, needs a lot of images being streamed into the neural network. So this allows to use S3 for that as well, instead of having to attach a file system. So the main advantage I would say is that fast access over S3 API. Of course, the cost of storing data there in these directory buckets is higher. It's even higher than EBS. It's twice the price per gigabyte than EBS. So you should really keep the data there for these transitory operations, and move it back to S3 standard, or if you want to keep that data and not leave it there. So it's mostly for access. So the cost of accessing the data is lower, but the cost of storing data for a long time is going to be higher in that
Mhm.
storage class.
Yeah, so definitely not a long-term storage.
Yeah,
As you mentioned, for those interim periods where you're actually doing something with that data, right? It's
exactly.
either like pulling it in,
Yes.
doing work, and yeah, getting the results out.
So
And yeah.
I suggest you look at another feature of S3 when you start thinking about workloads that could use this, is the S3 batch operations that allow you to do this, moving of large amounts of objects into between buckets. And this allows also to move between S3 old style or standard buckets into these new directory buckets. So batch operations already supports that as well.
Mhm. I'm also curious to ask about the standard S3, right? So as far as I remember, there were limits on performance for prefixes, right? So basically, well, folders,
Yeah,
prefixes. And these are now lifted for this kind of S3 type.
exactly. Yeah, this works in a different way. So there is no need to split or to kind of for scaling. You don't need to think about prefix in order to get that
Separation, yeah, right.
higher. Exactly.
Yeah. But it feels like that you guys are actually rebuilding the plane while in flight.
Yeah,
It's still using the same API, still using the same look and feel, but the products are
exactly.
vastly different underneath,
But
I guess.
and that's what APIs allow you, right? That's the whole idea of AWS, starting with this idea that you have a contract. This is what you expect to send and what you want to get back, and then the implementation is left to evolve. And the whole talk about from Werner Vogels about evolutionary architectures.
Mm.
He has been talking about that for many years already, and that's really what you see here with S3, is that you have the same API. However, the backend is allowed to evolve and provide new features and better performance and so on.
Yeah, cool. Uh, And since we mentioned about some kind of batch jobs that you would do in S3, most of the times those are related with some ML machine learning models that actually have to pull in some training data, train or give up the results. And one thing that was announced was EC2 machine learning capacity blocks. From what I understand, there was a problem for customers before that they wouldn't necessarily have the needed amount of GPU compute power whenever they liked, right? So they would hoard the the instances and don't let go just because they would have the capacity when they need it. And it's counterintuitive, right?
So you pay even when you are not using,
Yeah, it's
just
not
to keep the
intro
instance from, yeah, because that's how it works. If you choose an instance on demand, you will have it until you shut it down. It's not like with spot instances where you might even lose the running instance, but you get it at the discount, of course. But yeah, these new capacity blocks, super cool, I think. I mean, the other option of not holding onto your instance would be to continuously retry at another time or in another region, another availability zone, because capacity is dynamic and it changes across the regions. So if you have that flexibility, that's a way to get around that. But capacity blocks basically guarantees you that at this time you will have the capacity. So that's a great, and you don't need to pay for keeping the instance running.
And it was in a kind of similar way as EC2 Arise, like was it scheduled or reserved Arise?
Reserved instances scheduled.
Yeah, the
I
one
believe that was. I believe those were taken away. I don't think they are available. Scheduled reserved instances. But I guess it's a similar, right? It's a similar construct.
Yeah, you pay a little bit for ability to be able to run it at the schedule that you decided, and yeah, it's kind of
Yeah, I wonder. I need to check this, but I wonder if you can release the capacity block. Like, so if you reserve it, can you then choose not to use it when you get to that? That I have to check. But I think with reserved instances, schedule reserved instances, if you had purchased and then you use them, I mean, no matter if you launch the instance or not, you are paying that.
Yeah, as for it, right?
Yeah.
Yeah, but interesting news, because interesting problems that AWS is solving and getting by. Yeah, you would never think that people would just hold on-demand instances just for the time that they need. It's
exactly
interesting.
Yep.
Okay, and since we mentioned our dear friend Werner Vogels, yeah, I liked his whole speech. His whole keynote was dedicated to his observations for like the past 20 years or so, what's happening in the cloud and what he is advocating for. And what I heard is be cost-minded, be effective, run what you need, re-architect, redo, monitor stuff. I mean, these are all things that are no news for cloud-based workloads. Like we all should be doing that, but we sometimes forget. And yeah, and he brought these points home from another point, which is actually sustainability. And sustainability is a really close approximation to the cost that you actually spend, because running resources actually cost you money because they use some other resources, right? And in most of the cases, it's just upfront costs and electricity costs. And since if you can run your workload more effectively or less of it, you're going to use less resources. You'll be more sustainable. And this is kind of it's not a new point, but it was really emphasized that customers should also be thinking about it when they are thinking about their sustainability goals. And for example, there's coming new regulation for bigger companies to provide sustainability reports to the government now, and they have to think like how can they reduce it? And this is one of the ways: just run your infrastructure smarter. It will be cheaper. It will be more sustainable.
Exactly. Only benefits. Of course, it is aligned with cost, but it's also where you run it. If you think like, running, for example, you could have the same resources, but if you run it in a data center operated by AWS that is powered by wind energy or solar power, of course, it's also, it is the same resource, but the power source is different and the efficiencies at work are different. So basically, there are studies out there that between 3 and 5 times more sustainable, more cost-effective, and energy efficient to run workloads in the cloud versus running it in your own data center. So yeah, that I think it was a huge point by Vogels to talk about sustainability and basically saying that you cannot avoid this discussion. It will come everywhere. If you are not talking about it now, you will be talking about it. Yeah, exactly. We are talking about it. So yeah, it's and yeah, the angle on the cost definitely, like I mean, those were excellent points that it's also sustainability of the business, right? Now talking not about the environmental sustainability, but the business, because we are in an economical environment where you cannot just burn money. And there were times where you could just just to prove your point, you could run whatever, and there were investors out there for that. However, now you do need to align, with what you expect the business to grow from. So basically, your cost should be aligned with the revenue. It should lead to profit at some point. So yeah, really important points. Probably many people already knew them, but it was good to have that this framework to think about it.
Yeah, because sustainability, as you mentioned, isn't the environmental. It's also the cost. If you burn money on infrastructure that's unnecessary,
Exactly.
it hurts your business in the bottom line, and it's not sustainable to do reckless stuff on cloud.
Yes.
Yeah, and one of the laws that Werner's mentioned is that to make cost a non-functional requirement. Like, yeah, when we are building applications or whatever the business needs to do, we have some requirements, and yeah, sometimes cost can be afterthought in applicational development. Yeah, we need this kind of functionality, this kind of application, and we will run it on AWS. But how will we run it, or how much will it cost? That's yeah. We basically set the budget, then when we skyrocket through it, what next?
Exactly.
That's not a good approach.
And understand the trade-offs. Of course, if you want a really highly available, your application has the lowest latency and the highest availability, runs in 5 different regions, that will cost you a lot of money. And maybe for the business, the improvement or the kind of the extra traffic the business will get is not going to be that significant. So yeah, you need to think about those trade-offs. That's why he mentioned making it a non-functional requirement that you should compare against other requirements. Like, of course, he mentioned some of them are non-negotiable, like security. You never compromise on security, right? But others, like availability, performance. I mean, you want performance, but there is a place where you don't get that much benefit of the extra performance. So maybe you should focus on something else. So that's, I think, an interesting viewpoint.
Yeah, he also mentioned that you have to put your extra costs where it brings your extra money. Basically, not really going all over the architecture and making it beefier and bigger, perhaps re-architecting and making the parts that are bringing you the actual cash cows that actually have to work, because that's how your organization is making money. And those parts have to be taken care of meticulously, and you have to improve them, you have to re-architect them, you have to make them agile, you have to perhaps employ graviton processors there, because if you need to scale it, it will be expensive. But if you can bring the cost down and architectural decisions that you make, allowing it to scale, not linearly with the amount of computation you have to do, but for example, less than linear, you're getting bang for your buck. You're getting more sales. You're spending relatively less for the compute power. So these decisions, as you mentioned, these are all trade-offs, but it's just pointers where to look. And I really like them, because some areas are more important than others, I would say. Yeah, security, as I mentioned, non-negotiable, but many components of the application that comprises it, yeah, some of them really have a really small impact, while others
exactly. And he also talked about observability and getting insights from. So in order to make those decisions, you need to also observe, monitor. And there was the announcement, the My Applications announcement, where you can kind of aggregate all the different signals from one application or one workload into one common place, one common dashboard, let's call it. Exactly. In order to make those business decisions, you need to have visibility into what parts of your stack are slow or could be optimized, and then revisiting, like evolving the architecture, looking what is there new, like Graviton, there is the new generation, would it make sense, how big of a work would it be to change to Graviton, and what's the benefit we get from it? So kind of like not relying on what has been working, being kind of like the way forward always, but revisiting those decisions that were made, and looking at cost.
Yeah, you have to pursue that cost efficiency where it makes sense, and yeah, you have to be aware of the abilities that AWS provides, and because there's innovation, non-stop innovation, and yeah, as you mentioned, new instances are launching, new services are launching, and you have to, if you want, you can make use of it. And they are solving very specific problems most of the time. And if you do have it, why not make use of it, right? So in most cases, it makes sense not solving the same problem that you already solved in some way. And when AWS comes out with a solution, I mean, at least evaluating if it's better or it's more cost efficient. Yeah, that's an interesting approach. And yeah, as I mentioned, monitoring is also very important, because without monitoring, you do not know what should you improve or what you can improve. Because what Werner also mentioned is that seeing the metrics themselves, showing the metrics to the team or customers, changes the behavior. And basically, you see how your actions influence those things. And yeah, well, the more of the metrics you see, uh, and you know what the goals are, you know what kind of development has to be done in order to move that metric up and down. It's a cool concept that not many companies actually use.
That is exactly right. That is exactly right. That's something I have observed multiple times, where customers don't really have an understanding of the cost impact of different features or different workloads, and having that visibility and having the teams responsible for those workloads understand the cost and be able to compare with the cost of other features and other workloads, getting a sense of, is this reasonable or not? That's something that is still lacking across many, even advanced customers. We know a lot and they are tagging, but they still lack this team awareness of the cost and the evolution of the cost in their specific workloads.
Yeah, it's more like a generic, broad FinOps problem for organizations, right? Because we do have kind of silos where we have developers, where we have DevOps. They don't talk too much. Then we have DevOps and finance. They don't talk too much. They said they asked us to deploy this, so we deployed that, and it caused this. And yeah, they have to work as a team. They have to be on the same boat, and do understand. And DevOps could say, "Hey guys, if you want this to run this way, this will cost you X amount. But if you want to be more agile or improve these architectural changes, this will cost you Y amount of money." And FinOps would say, "Yeah, let's go for Y." Then developers can actually make some changes and adjust it, while those upfront costs won't be that high as for like maintaining that infrastructure and running it. And it's like a team game, the FinOps. And yeah, those team silos who don't talk to each other or understand the end result of the cost is quite a challenging thing in organizations. It's something a bit new still.
Maybe, Jonas, we should coin the term DevSecFinOps as the new next wave of IT evolution.
Oh yeah, cool. Any other topics, Miguel, you would like to touch on?
No, I think, I mean, I would be curious to know from your point of view, what were kind of the announcements that got you most excited? What were the things that maybe something you were expecting already to have or were looking forward to have, or just something that impressed you? You already mentioned a few, but do you have like one?
I'll actually get back to those that we actually covered because those were interesting to myself in the first way. But actually, the most interesting one was the Aurora serverless, the limitless version of Aurora, because I did previously some consultations on big RDS databases, and the limit where that consultation ended is, hey guys, you need to shard your database. And now this is now lifted, and the ingenious way how this was done, and it's a managed way how it was done. It's really opening some doors for some of the customers, and it's just spreading the word that it's actually now possible to do this is actually really exciting. And another thing as well, yeah, the Bedrock introduction, that AWS was working for quite some time with it, and waiting to make it right, to make it comprehensive offering, and not like, yeah, we're going to only offer our Titan model and we're done with this. No, no, no. They're bringing a suite of other well-acknowledged models, and customers now have a choice. While not moving anywhere from AWS, they have a choice to use different types of models, whichever is suited best to their case. So I think these two are the huge news, two huge news for myself that I really, really like. And yeah, what
I hope
are
to
your
see
thoughts?
this. Yeah, definitely the Bedrock. I mean, being in the area I'm in, and customers have been asking about this, and I see, yeah, the security tips, the integrations with the other AWS services. I see a lot of customers starting to build with Bedrock already, so that's pretty cool. And yeah, looking forward to see Limitless in the wild as well, and see all these new features being adopted. So yeah, curious about where the customers will turn.
True.
Yeah.
AWS also doesn't know everything, so
No, exactly.
future will tell.
Yeah.
Yeah, and as a closing word, yeah, thanks, Miguel, for really nice roundup of reInvent announcements. It was a really pleasure to have a discussion with you.
A pleasure for me as well. It's great
I've
having
learned a
it.
lot.
Yeah, me too. Actually, I thank you for having this or creating this format. It's a really nice new format to discuss about these things. Yeah.
Yeah, definitely. I hope you enjoyed it as well, and yeah, hopefully our customers will also get a few bits of great information out of our discussion and employ them into their infrastructures. And yeah, thanks a lot. And as a closing remark, I would say, don't forget to um, architect your infrastructure as the frugal architect, as Werner said. So there is a link, there's a webpage, thefrugalarchitect.com, so you can guys visit it and see for yourself how those great architectures on AWS should be built and can be built. Yeah, thanks a lot, Miguel, and once again,
Thank you, Jonas.
see you next time. Yeah, see
See
you
you
guys.
next time. Bye, everyone.
Bye.